GM deploys IONATE smart transformer at Michigan plant. General Motors plans to deploy IONATE's hybrid intelligent transformer technology at its manufacturing facility in Romulus, Michigan, in what will be IONATE's first U.S. installation. The deployment comes as GM expands production capacity at the 900,000 square foot facility, which manufactures 10-speed transmissions for full-size trucks and SUVs. GM has invested $300 million in the plant as part of that expansion. IONATE's technology is intended to give the automaker more detailed information about electricity consumption, power quality, and conditions at the plant's connection to the grid. The project will also test whether more active control of those conditions can support manufacturing reliability and energy resilience. Smart Transformer adds real-time power monitoring and control. IONATE's Hybrid Intelligent Transformer, or HIT, combines conventional transformer functions with power electronics, sensors, and digital controls. Installed between a utility connection and a facility's electrical systems, the equipment monitors electrical conditions and can respond to certain disturbances as they occur. At the Romulus plant, the system is expected to provide consumption and power quality measurements at sub-millisecond resolution. That level of visibility could help plant operators identify voltage fluctuations, harmonics, reactive power issues, and other electrical conditions before they interfere with production equipment. The technology is also designed to manage some of those conditions locally, rather than relying solely on upstream grid equipment. For industrial facilities with increasingly automated and digitally controlled operations, that capability may help reduce exposure to power quality events that can disrupt sensitive equipment or production processes. GM manufacturing executive Luis Cervantes said in the company's announcement that efficiency and resilience are priorities for the automaker's manufacturing network, and that the project is intended to improve energy management while supporting the wider grid. GM and IONATE engineering teams have been working on integrating the equipment into the Romulus facility. The 3 MVA units, designed to comply with relevant U.S. I2E requirements, are undergoing final construction and testing ahead of installation. The companies could consider additional deployments across GM's manufacturing network following the initial project, although any broader rollout would depend on the results of the Romulus installation. The project also gives IONATE an entry point into the U.S. industrial market following earlier work with electricity networks in Europe. Industrial electrification puts more focus on grid connection points. The GM installation reflects a wider challenge facing manufacturers, utilities, and other large electricity users, adding electrical capacity and improving reliability without depending entirely on major transmission and distribution upgrades. Industrial electrification, growing data center demand, distributed generation, battery storage, and more variable power flows are placing additional demands on infrastructure that was often designed for relatively straightforward, one-way electricity delivery. IONATE's approach concentrates additional sensing and control at the transformer, a critical connection point between the grid and large electrical loads. Its HIT equipment is designed to fit into existing substations and industrial electrical systems, potentially allowing operators to add digital monitoring and power management functions without replacing the wider network. The company reports operating efficiency of more than 99% for the technology. It also estimates that, under average deployment conditions, its system could allow networks to accommodate about 33% more distributed energy resources and carry roughly 25% more power without equivalent upgrades to poles and wires. IONATE estimates potential power loss reductions of around 6%. Those figures are company projections rather than results from the GM installation, and actual performance will vary according to grid design, operating conditions, and deployment scale. IONATE's transformers can also connect with its Aurora software platform, which coordinates data and control functions across multiple HIT units. In a larger deployment, the software is intended to allow individual transformers to operate as distributed control points across a facility or electricity network. For manufacturers, that could provide a clearer picture of how grid-side electrical conditions affect plant operations, while creating additional options for managing voltage, reactive power, and other power quality variables closer to the equipment using the electricity. Industrial facilities are becoming an important proving ground for this type of grid technology because they combine high electrical demand with relatively concentrated connection points. The Romulus project will offer an early U.S. example of whether transformer-level monitoring and control can deliver practical reliability and energy management benefits in a large manufacturing environment.